What if Earth had two suns? Would we get two sunsets, two shadows, and most importantly, would we get four rainbows? Rainbows already come in pairs. The bright rainbow we usually notice is the primary rainbow, and just above it, under the right conditions, you can sometimes see a fainter secondary rainbow. But those aren't the only rainbows that exist. Inside a single raindrop, sunlight can take different paths as it enters, bends, reflects, and exits. Those different paths can create third, fourth, and even fifth order rainbows. They're just so faint that they're incredibly difficult to see. So what happens if we put two suns in the sky? Well, it depends on where those suns are. There are two main ways a planet can exist in a two-star system. The first is a planet orbiting both stars. That's called a circumbinary planet, basically the real-life version of Tatooine. The second is a planet orbiting one star, while the other star is much farther away. That's called an S-type orbit. On a planet like that, the two suns could appear in completely different parts of the sky, and the distant sun might even look no brighter than our moon, or possibly just like a very bright star. But Tatooine is different. Its two suns appear close together and similar in size and brightness, suggesting that the planet is probably orbiting both of them. And if you had two equally bright suns, you'd get something spectacular. Two overlapping primary rainbows and two overlapping secondary rainbows. Here's where it gets really interesting. A primary rainbow forms a circle roughly 84 degrees across, centered directly opposite the sun. So the farther apart the two suns are in the sky, the farther apart their rainbows would appear. If the suns were 84 degrees apart, their primary rainbows would barely touch. But there's a problem. A planet orbiting two stars can't simply get as close to them as it wants. The combined gravity of the two stars can make the planet's orbit unstable. For two stars of similar size, the planet generally needs to orbit at roughly 6 times the distance between the stars to remain stable. And that means the two suns on a Tatooine-like planet would normally never appear extremely far apart. They'd stay relatively close together in the sky. So their rainbows, they'd overlap. And where those rainbows crossed, their colors would blend together, creating a much more complicated and potentially spectacular pattern. And remember, we're not just doubling the primary rainbow. The secondary rainbows would overlap too. And theoretically, the fainter, higher-order rainbows could join the party as well. So instead of the simple rainbow we're used to seeing on Earth, you could have a sky filled with layers of overlapping rainbows. And of course, if two suns mean two rainbows, does that mean two pots of gold? Probably not. But we definitely have to rewrite a lot of our rainbow myths. Because on a two-sun planet, even a rainbow wouldn't be just a rainbow anymore.